First off, let's start with the easy part. The easy part is the variables. Okay, the x squared and the y third. If I just want to factor that, what times what gives me x squared? No. X times x. If I multiply that out, I get x squared. Look at the y's. Y times y times y. If I multiply that out, that becomes y to the third. Because when you multiply variables, you do what to their exponents? You add them. Let's say if I had a y to the 20th. If I wanted to factor it out completely, how many y's would I write down? I'd write down 20 y's. How simple is that? Does everybody understand that? So I should, Josh, hush. So no one should miss the variables. There's x squared, you write down 2x's. There's a y to the third, write down y times y times y. Because if you multiply those out, remember you're adding the exponents. So x times x is actually x squared, and y times y becomes y to the third. Adding all those exponents. Now, so we're done with the easy part. Now let's move on to the number, or the coefficient. Remember, that's the number in front of the variable. Okay? You should have learned this in your past math classes about factoring a number. This is all you're doing here. When you have 18, I think the easiest way to factor a number is use a factor tree. I think that's very, very simple. I know that what times what gives me 18? Well, 9 times 2.
6 times 3.
18 times 1.
Well, you can start out 18 times 1, doesn't matter. You can.
9 times 2, then goes 3.
What times what gives me 9?
3.
3 times 3. Okay?
So you can't get anything from it.
So, now remember with the factor tree, the numbers at the very end of the, you can call them roots or the lines, are your numbers that you're going to write down when you factor them out. So, I have nothing else connected to this 3. I have nothing else connected to that 3. And then at the end of the last root is 2. Right? Now, make sure when you factor it out completely in factored form is considered, I'll read over this paragraph. Factored form is when it is expressed as a product of prime numbers and variables. And no variable has an exponent greater than 1. So, prime numbers. Does everybody know what that is? Only way you can get to them is if you multiply 1 or times itself. 1 times itself. So, 9 is not considered a prime number because I can multiply 3 times 3 and get to 9. 3 is considered a prime number because there's nothing I can multiply to get to 3 besides 1 in itself.
Pretty much odd numbers, isn't it?
Yes, but 9 is considered an odd number, so... Typically they are odd numbers, though, of course. I mean, if you had an even number, you can always cut them in half. Does that make sense? So, does everybody have this written down? So this bottom line is going to be your answer. Just put the end, if you want to use that factor tree, just put the end of the roots right there. 2, the 3, and the 3, then your variables. Any questions? Fairly simple. So that's going to be your answer. Let's see how we got it. 15. How do we factor out 15? Well, use a factor tree. What times what gives me 15?
15 times 1.
5 and 3.
15 times 1.
Now, Anthony said 15 and 1. Well, you are right.
But it's just like keep going on forever and ever if you don't keep going like that.
But you're not getting anywhere. Shh. Okay? You're not getting anywhere like that. So 5 times 3 can give me 15. Can we factor out 5 again, or can we factor out 3 again? No. So they're the end of our roots. So just write your numbers down there.
Mr. Schwab, didn't we do something like this in the last
We
semester?
did.
So we're going to factor each one of these completely. Kenny suggested 9 and 3. That is right. And for 9, you can factor it out as 3 times 3. Can we? Sorry. What's your question? Can I factor out 3 anymore? No. So these are my ends of our roots. That's why they call it a factor tree. They're not connected to anything else. Okay? Now the easiest part is the a squared and the b. That's very, very simple. So I'm going to write down my 3 times 3 times 3. Those are my end of my roots. And then my a squared is just going to be a times a. And my b is just going to be b. Now, let's talk about the next term. 15 a and b squared. So if I want to use my factor tree, I'm going to go ahead and factor out 15. 5 and 3. 5 times 3 gives me 15. I cannot factor out 5 anymore. Can't factor out 3 anymore. So those are my numbers. Okay. My variables, I have 1a and I have a b squared. So b times b will give me b squared. Why'd I do that? Oh, and the c. Oh, I'm sorry. Yes. Thank you. Sorry about that. Now, what is one way we can check if we factor it out correctly? You can use a calculator, or you can think in your head. You can just multiply this out. 3 times 3 gives me 9. 9 times 3 gives me 27. Good, I factored that out right. A times A gives me A squared. Okay, I factored that out correctly. And then, of course, B is all by itself, and B is all by itself here. Same thing for this bottom one. 5 times 3 gives me 15. Okay, I did that correctly. You can always check your answer by doing that. Now, let's talk about the greatest common factor. Now, all it is, the reason why I had you factor each one of these out completely is because the easiest way to determine this is to circle which ones they have in common. What I mean by that is, I got a 3 right here and a 3 down here. What else do I have in common? I got an A right here and I got an A down here. I have a B right here and a B down here. Are those my only common terms? Yeah, you're right. So, after you've circled or drew a line, whatever, however you want to do it, circle, draw line, doesn't matter to me. After you do that, if I circled a 3 so that they have a 3 in common, so I'm going to write down a 3. I circled an A because they have an A in common, so I'm going to write down an A. And notice I'm putting multiply beside of them. I circled a B. They had that in common also, so I'm going to write down B.
So the answer is 3 and B.
Absolutely. Last thing you would do is combine all of it. It's fairly simple. Write down 2 X's. Y to the third tells me I have 3 Y's, so I'm going to write down 3 Y's. On to 26. X and y to the fourth.
Oh, I think I figured it out.
3 and 2, 13 and 2.
So it's going to be 13 and 2. Good. 13 times 2 gives me 26. And 13 is a prime number. X. I'll just write down 1. Y to the fourth. I have 4 y's. So 1, 2, 3, 4.
So,
Now,
would,
Josh, hush. Now let's circle, or you can mark out, doesn't matter, our common factors. Well, I have a 13 here and a 13 up top. I have a X and an X. I have a Y and a Y, a Y and a Y, and a Y and a Y.
Mr. Shaw.
Yeah.
So, would it be like, if, okay,
I'm going to write down what I found. Now, a common mistake is, 13 is a common factor, and I circled 2. A common mistake is some people would write down 2 13s. Okay, if you circled 1 13, 13 is a common factor of both of them. Just write down one of them. I have an X. And I have 1, 2, 3 Y's. Last thing you need to do is put them all together. Well, 13, X, Y. How many Y's do I have? 3. So, that's what you should have got. First of all, you can tell by the numbers 49, 7, and 14. Well, the greatest common factor is only going to be 7 because, first of all, they all have a factor of 7. Second of all, none of them, all 3 of them are not greater than 7. Make sense? Now the X's, you can look at that also and see that the third one, there's only one X. So at most, you could factor out one X. For the Y squared, please, that's annoying me. Turn.
I'm trying to listen to you. I'm not even doing anything.
Okay, I trust you. Y, okay, for the Y's, the greatest one I have is Y squared. I got a Y to the third and Y to the sixth. But the highest one I can pull out is Y squared. Same thing for the Z. I only have one of the Z's in the first one, 49. X squared, Y to the third, and Z. So the most I can factor out is Z. Simple, right?